video, we are going to talk about absolute error and also the relative error. So these are the two things that we're going to talk about. So absolute error and also relative error. So before we talk about this absolute error and the relative error, the first thing that we're supposed to know is the definitions. What are these absolute error? When they say absolute error, what is it? Or when they say relative error, what is it? So by definition, absolute error is the actual value of the error, including the proper units. So absolute error is the actual value of the error, including the proper units. That is the definition, or that is the definition of the absolute error. And then this absolute error, it has got two formulas. There is this formula which I'll explain, and then the other formula this side which I'll explain as well. So these two formulas, the first one it says the absolute error, where there is AE. AE stands for the absolute error. So AE stands for the absolute error, and also the RV stands for the recorded value. So RV stands for the recorded value, and then TV, stands for the true value. So where A is, whenever you see AE, it simply means that these are initials that I'm just using. So AE, it simply means absolute error, and then RV, it simply means relative value, and also TV, it simply means a true value. So we say, which is absolute error is equal to the relative, the recorded value, take away true value, and then magnitude. These two stands for the magnitude, or stands for the bars. So I'll explain what these bars are doing here. And then O, which is the other formula, is the absolute error is equal to 1/2 multiplied by, which is half, multiplied by least unit of measurements. This M stands for the measurements. So the least unit of measurements, that's what it stands for. So absolute error is equal to half multiplied by least unit of measurements. That is number 2, the formula number 2. So it's either you can use this one or you can use this one. So I'll show you how to know which formula you're supposed to use. So the first one, it can only be used when you have been given two values, which is the recorded value and also the true value. That is when you can use the first formula, which is the absolute value, absolute error is equal to the recorded value, take away the formula which can be used when you've been given two values. And then when you've been given one value, which is the least unit of measurements, the least unit of measurements, which simply means one value, then you're going to use this one. So which is half multiplied by the least unit of measurements that is given in that statement. So that is about absolute error. And then we go to relative error. Relative error is the relative error of your absolute uncertainty compared to your actual value. That is the definition which is there. So remember what I said at first. I said you are supposed to know the definitions. So you're supposed to know the definitions before you know how to solve this type of questions. So relative error is the relative error of your absolute uncertainty compared to your actual value. And then the relative error is equal to, this is the formula. So relative error is equal to the absolute error divide the true value. So absolute error divided by true value. So absolute error divided by true value. That is the relative error. Examples. So examples, the first example is a teacher measured a length of a line to be 2 meters. If the actual length is 3 meters, this is our true value. So I've put TV here, and then here I've put RV, which is the recorded value, and also this one is our true value. find the absolute error and also the relative error. So you have been given two things. You have been given the recorded error, the recorded value, and also the true value. Those are the things that we have been given. So how do we find? How do we find the absolute error? So absolute error, we are going to use the first formula, which says that absolute error is equal to magnitude, which is the bars, and then the recorded value minus the true value. So the recorded value in this case is 2, which is here. The recorded value is 2, which was measured by the teacher. And then the true value is 3, which was the actual value. So this is the actual value, which is 3. And then we subtract 2, take away 3, it will give us negative 1. So the absolute error is equal to magnitude and then negative 1. So here is now where these bars works. So these bars, they just work where they see a negative sign inside. So if a number is in a negative form, then it is supposed to be changed to a positive form. But if a number is in a positive form, you don't have to change it to a negative form. It will still remain as a positive form, in that positive form. So this one is in a negative form. So that's the reason why we have said the magnitude of this negative one is a positive 1. So we have put the positive 1 there. So that is the value. So the absolute error is equal to 1 meter. We go to the relative error. Relative error is equal to the absolute error over the true value. So absolute error over true value, that is the relative error. And then the relative error is equal to, so 1, absolute error we have found to be 1. So 1 over 3. 3 is our true value. And then when we start dividing, which is 3 into 1, so 3 into 1, it's a 0. And then we put a point, and then we add a 0 there. That's how we divide fractions. And then also 3 into 10, it will give us 3. And then remainder 1. From this one, we add another 0. 3 into 10 again, it is 3. Remainder 1. So it will just be giving us 3, 3, 3, 3, 3 that side. So the fact that it is giving us 3, 3 this side, which simply means that these are non-terminating decimals. So for non-terminating decimals, what we do is that we just put a bar there, which simply means that these 3, 3, they are repeated several times without stopping. So that is the actual value, which is the relative error. This is how we find the relative error. See you in the next video.